This is the Usibelli coal mine at Healy in interior Alaska. Today, the Usibelli mine is a model of modern mining technology. A far cry from the days when pioneer Alaska developer Austin E. Cap Lathrop first began mining here over 60 years ago. In 1918, construction on the Alaska Railroad reached Healy 250 miles north of a tiny port community called Anchorage, 100 miles south of the bustling gold center of Fairbanks. For 4 years, horse-drawn sleds hauled the first coal 4.5 miles from Suntrana to the railroad. Then in 1922, a spur was completed, linking Cap Lathrop's Healy River Coal Corporation to the main line. In those days, the mine's only customers were in and around Fairbanks. In 1943, an Italian immigrant named Emil Usibelli opened his own strip mine at Suntrana near Healy. He had 1 tractor and 2 trucks. Others laughed and took bets on how soon this chichaco would fold. But there was a war on, and Usibelli convinced military officials at Ladd Field near Fairbanks to give him the contract to supply their power plant. Emil Usibelli was off and running. In 1950, Cap Lathrop was killed in a mining accident, and his mining operations were sold to Suntrana Mining Company. 11 years later, Usibelli bought Suntrana out. In 1964, a mining accident claimed the life of 71-year-old Emil Usibelli. Suddenly, his 25-year-old son, Joe, a graduate student at Stanford, was in charge of a multi-million-dollar operation with annual sales of just under 400,000 tons of coal. Joe Usibelli quickly proved himself capable. Over the next 2 decades, in-state sales more than doubled to 800,000 tons per year. By this time, Usibelli's customers included the Fairbanks Municipal Utilities Plant on the banks of the Chena River, the University of Alaska plant at College, a large plant at Eielson Air Force Base, 26 miles southeast of Fairbanks, Clear Air Force Base near Healy, the old Ladd Field plant renamed Fort Wainwright, and Golden Valley Electric Association, serving the outlying areas around Fairbanks. And today, a small but unique customer is Reliable Coal in Healy, providing retail coal sales to residents and small businesses in interior Alaska. And in 1984, Usibelli Coal became the first significant exporter of an Alaskan mineral resource with the signing of a 15-year contract with the Sun Eel Alaska Corporation to supply over 800,000 tons per year to a power plant in Honam, South Korea. But at 1.6 million tons per year, Joe Usibelli feels there's still room for growth.
We think that our optimum efficiency at this point with the current fleet of equipment and the way we're structured now is probably somewhere between 2 and 2.5 million tons a year.
Over the past 2 decades, Usibelli has built a state-of-the-art operation using the latest equipment and backing it up with a computerized, automated parts inventory system.
A mechanic will come to the warehouse, ask for the warehouseman for a specific part. Warehouseman will look it up in the parts book, locate it on the computer. Computer tells where it is located. When it's checked out, everything in the history of that part is updated. The number of parts on hand is subtracted. The cost of that part plus a stocking charge is charged the operating cost of that piece of equipment. Most of the smaller parts are located in the mini tree, what we call the mini tree, which is a computerized robotic storage device that has 728 bins. The bin number is entered into the machine and it retrieves that drawer for you automatically to the same location, always. You can store many parts in a very small volume.
But though the equipment may be new, the process has remained basically unchanged.
You first have to delineate the resource, find out what you have, where it is, what the stripping ratios may be, what the quality is.
You have to start with some base of knowledge, which usually on a very rough terms, would be the outcrops of the coal, that you can see coal outcropping on a cliff face or whatnot. And from that, you can usually get an attitude of it and get an idea of where the coal is heading, how thick it is, the structure of the coal. And then what we do is lay out a series of drill holes, locations, and we can sink a hole down into the ground in a known location. We'll survey that location in so we get coordinates and an elevation on it. And then as we drill the hole, we see what is coming out of the hole. And when we hit a coal seam at a certain depth, we record that, the thickness of the seam. And then backing out from the coordinates and the elevation, you just subtract that, the depth that you hit the coal seam at, and you would know where the coal is. And then you use the computer, basically, and you can manipulate it through a series of mathematical formulas and whatnot to create a three-dimensional model of the coal seams. Creates a three-dimensional image of that, and you can run plan views of it, so you can run structure maps to see what your coal is doing structure-wise, which way it's diving or dipping, thickness maps of the coal seams to see if it's pinching out or expanding in certain directions. You can run cross-sections, so you can see a cross-sectional view of what's going on, and then it'll also calculate volumes for you and tonnages of coal and stripping ratios, or the yards of overburden that you would have to remove to recover X number of tons.
And a lot of this is concurrent. You're probably doing some of the engineering as you're doing some of the exploration. And design a mine. A mine is like any other technical thing. It is engineered, it is designed. The next phase after it's designed would be the removal of the overburden. And that is a fairly complex operation involving removal of part of the overburden which doesn't need to be shot, benching, drilling, shooting, and then moving the overburden, primarily with the drag line. It's a Bucyrus series machine. The model is a 1300W, which we purchased, started erecting in 1977 in November, and finished erecting just short of a year later.
The machine weighs 4.25 million pounds. The mast is 186 feet high. That's the mast straight up there, and the boom is 325 feet long. That's a 33-yard bucket. You get a pickup or two in it, I would imagine. We think we're capable of moving 22 million yards in 1 year.
It side casts the material, cutting a long, narrow pit. About 105 feet of coal is exposed. And at the end of that, it turns around, comes back, refills the hole where we've now removed the coal, and makes the next cut. Secondary stripping is with a shovel and truck. 16-yard O&K machine made in Germany. It puts the material into trucks where it is hauled to its final location. Working with that are our trucks, which are 75-ton WAPCO units. They're powered by 725 horsepower engines, I believe, and are used in two parts of the operation. We use them as they are originally manufactured with rock boxes on them to move our overburden.
Some of that overburden is used to build and rebuild the network of roads throughout the mine site. As the equipment moves to a new mining location, so must the roads.